Thank you for joining EdPlace live lessons from your homes. I'm Miss McCall and you've joined us for a maths lesson today. If this is your first visit to EdPlace, here is a quick summary of what we have to offer. We're an online digital learning platform written for students Year 1 to Year 11, offering English, Maths, Science and 11 plus self-marked activities written by fully qualified teachers. We're bringing English, Maths and Science lessons into your home during the school closure period, so why not join us over the next few weeks as we tackle some key topics. You might find it useful to have a pen and paper handy as we go, so that you can make a note of key ideas or jot things down. So welcome to today's GCSE maths lesson on highest common factors with Miss McCall. By the end of today's lesson, we're aiming to have achieved either one or all of the following three steps. Be able to understand the key terms associated with highest common factor. Apply your knowledge to break questions down to manageable chunks, and to be able to explain your reasoning at the end with confidence. One of the most important things in maths is to understand keywords. These often give us a clue on how to answer a question. So for example, factor. We know that this is a number that divides into another number equally. From the examples we can see the factors of 8 are 1, 2, 4 and 8, and the factors of 24 are 1, 2, 3, 4, 6, 8, 12 and 24. Prime number. Well, prime number is a number that only has two factors, that is the number 1 and itself. For example, the factors of 3 are 1 and 3 because they're the only two numbers that will divide into it. Equally, the factors of 2 are 1 and 2, the factors of 5 are 1 and 5, and the factors of 7 are 1 and 7. But beware, there are some common mistakes made. Many students think that all odd numbers are prime. But think about the number 9. It has three factors, 1, 3 and 9, and so therefore cannot be prime. The number 1 has only one number that divides into it, and that's itself. So that also cannot be prime. Then there is only one even number that is prime, and that is the number 2. Maybe this might help you remember the first few prime numbers. Oh no! 4, 6, 8 and 9 have been kidnapped. 2, 3, 5, 7 and 11 are the prime suspects. Common factor just means we're looking for numbers that are the same. Product of prime numbers. The word product means multiply. We quite often see that on exam papers. So all you'd have to do is multiply the prime numbers that you find. Generally, we're asked to find the highest common factor of two numbers. In our example, we're going to find the highest common factor of 24 and 36. The trick here is to break the question down and work with one number at a time. Here we're going to start with 24 and produce a prime factor tree. We are looking for two numbers that divide equally into 24. Here we can see that we have the numbers 2 and 12. We look at these numbers to see if one of them is prime. 2 is prime, so we can circle it, and that lets us know we've finished with that particular branch of the tree. Continuing on in the same way, we can see that 2 and 6 divide into 12. 2 is prime, so we can circle that. Finally, looking at number 6, we can see that 2 and 3 divide equally into it. As they are both prime, our tree is finished. We can now follow the same process to break down the number 36 into its prime factors. Here we can see that the factors of 36 are 2 and 18. 2 is prime, so that we can circle that. 18 has the factors of 2 and 9. 2 is prime, so again we can circle that. Finally, 9 has 3 and 3 as its factors. 3 is prime, so we circle those numbers, and now we have successfully broken out our second tree down into prime factors. Now, I know what you may be thinking, that other factors might divide into these numbers, and you're absolutely correct. As you can see here, both these numbers are broken down in a different way. The magic is, though, that we can see that the final factor tree is the same, so it doesn't really matter which way we break the numbers down. Once the numbers have been broken down into trees, we can use them to find our highest common factor. First, we put our answers down one underneath the other in ascending order, which will make the next part easier. As we can see, 24 is equal to 2 times 2 times 2 times 3, and 36 is equal to 2 times 2 times 3 times 3. One way to check our trees are correct is to multiply them to see if we get back to the original number. For example, with 24, we can see that 2 times 2 is equal to 4, times 2 is equal to 8, and times 3 is equal to 24. If this doesn't work, we've made a mistake somewhere on our tree and we need to go back and find it, or our final answer will be incorrect. And after all that work, we certainly don't want that. Now we're going to look to pair up numbers from each tree. We have a 2 from 24 we can pair up with 36. We're going to use this as our starting point. We can also see that we can match 2 again from both numbers. So let's use that. We can't find a pair for the other 2, so we can ignore that. We do have a match for number 3, so we can use that. Finally, we multiply these numbers together, and hey presto, we found our highest common factor. Now, we may be able to see this just by looking at the numbers. However, the sneaky examiners want to know how we arrived at the answer, so to gain full marks, we have to show our working out. Ah, great, bonus time. Now, as mathematicians, we're always on the lookout for ways in which to use our answers. Here we are lucky because we've done all the hard work of finding the highest common factor, and we only have to do one other step to find the lowest common multiple, which is often something we're asked to find. All we need to do is take the answer to the highest common factor and multiply it with the numbers that were not matched up in our calculations. So we can see here that the lowest common multiple of 24 and 36 is 12, which was our highest common factor, multiplied by 2, multiplied by 3. In a moment, I'm going to direct you to an activity you can use to reinforce and extend your knowledge. Please sign in to your EdPlace account, or if you don't have an account, visit www.edplace.com. The activity we are looking for is how to find prime factors. Whether you have an EdPlace account or not, we follow a similar path to find that activity. Those of you with an account go straight to Maths, and those of you without should click on the Learn tab and then go to Maths. After this, our route is the same. Go to GCSE and select the exam board you are familiar with. Click on Number and then scroll down to find prime factors. If you're having problems locating an activity, please visit our support site on screen for a quick walkthrough on how to locate the activity. First, I want to make sure we're all in the same place. This is the introduction you should be able to see. If you can't see this, go back to the worksheet to check that you've selected the correct one. If you can see this introduction, then you're ready to start. When you're ready, pause my lesson and start the activity. I will go through 3 questions with you in the next stage of the lesson, so don't worry if you get a little bit stuck. Let us review some of the questions, beginning with a prime factor decomposition. Now, mathematicians like to make things simple and so use index form to show the result of the tree. When using these trees to find the highest common factor of 2 numbers, it is easier to leave writing in index form until you have paired them up. Breaking down 324 into prime numbers gives us 2 times 2 times 3 times 3 times 3 times 3, which is shortened to 2 to the power of 2 times 3 to the power of 4. Factor trees are great for breaking down larger numbers into prime numbers. This question is just asking you to complete a factor tree in the usual way and list the prime numbers in ascending order. As you can see here, A is equal to 2, B is equal to 2, C is equal to 3, D is equal to 3, and E is equal to 5. All you've done here is you've looked at your tree and you've put everything into ascending order. On questions such as this, be careful. It is sensible to write out the product of prime numbers first. Take 60. This can be written as 2 times 2 times 3 times 5, and multiplying it gives us 2 times 2, which is equal to 4, times that by 3 is equal to 12, and times that by 5 gives us 60. The number 28 can be written as 2 times 2 times 7, which gives us 2 times 2 is 4, times 7 is 28. Now the number 100 can cause problems. We know that 2 to the power of 2 is the same as 2 times 2, which is 4. However, a common mistake made is that 5 to the power of 2 is quite often calculated as 5 times 2, which is equal to 10, when in fact it should be calculated as 5 times 5, which is equal to 25. Let us look at the difference this would make to our answers. 2 times 2 is equal to 4, with 5 times 2 is equal to 10, would give us an incorrect answer of 40. So 2 times 2 is equal to 4, and 5 times 5 is equal to 25, would give us the correct answer of 100. So that's why it's usually a really good idea to write out your index numbers as the product of their prime numbers. Let us recap on your work today. Are you able to understand the terms associated with finding highest common factor? Remember, these are often the clues as to what is required when answering a question. Were you able to apply your knowledge to break the questions down into manageable chunks? Can you explain your answers with confidence, giving reasons for them? Were you able to meet one or even all of the objectives? Great work, well done. We know that some of you will feel you need a little more practice to really master these skills, while others of you are ready for the next challenge. To help you know which activity to select next, here are some suggestions. The activity we've just tried is listed as Activity 3. If it felt a little tricky for you, why not try Activity 1 or 2 to gain confidence in the skills that you need? Then give it another go to see if you're more ready to tackle it next time. Good luck! As we finish up for today, here are the places you can find us or access support. We look forward to meeting with you again soon, and keep practicing in the meantime.